So in this unit, we are going to look at some advanced techniques of integration. All right, we've learned how to use U substitution and some other techniques for integrating. And now we run into some problems like these here. X squared times the log of x. Can we integrate that? X times e to the x. Can we integrate that? Well, if we look at these ones, we're going to run into problems with all of them. We might try U substitution. Maybe u equals x squared and du is 2x. Well, there's kind of an x in there, but it's in a log. That's just ugly, and that's just a problem. How about this one? E to the x. Well, e to the x is fine. However, we got this x times e to the x out here. We could say u is x, and this is u, but we just kind of end up right back where we started. Similar idea here. Sine of x by itself is no problem. E to the x is no problem. But multiply them together, and we have problems. All right? So we can't really integrate those. Now, if we look close, we notice that these are products of functions. So we've got x squared and natural log of x. They're products. Okay? So let's think about the product rule. So the product rule said this. If we take the derivative of u times v, where u and v are functions of x, well, we got to take the derivative of the first, du dx, times the second, plus the first times the derivative of the second. Or another way to write that, u prime times v plus uv prime. Okay, so there's our product rule from way back at the beginning of the year. Now, if we integrate both these sides, so let's integrate this and let's integrate this here. Well, we integrate the derivative and these kind of cancel each other out, leaving us with uv. And when we integrate this thing, all right, we can take the integral of them separately. And this right here, we have the integral of v u prime dx. Well, u prime dx there is just du. Because du dx is u prime, swing this over there, and there you go. That's du. So that's du, and this is dv, which leaves us with v du times u dv. All right? Integral of there. All right, so here it is. Memorize it. This is the key, and it just comes from the integral of our product rule. So the integral of u dv equals uv minus integral of v du. Okay, u dv equals uv minus v du. All right, notice it changes here. So we still have an integral, but the hope is that this integral is going to be easier to work with than the original integral. Okay, and of course, u and v have to be differentiable functions here. All right, so some guidelines here. The key is going to be picking what u and dv are. That's the key. We've got to carefully do that. So some thoughts here. We might try letting dv be the most complicated part of the integrand here. That fits the basic integration rule, all right, because we're going to have to integrate that. Okay, and so let u be the remaining, and then hopefully the u will go away there as we take the derivative. Okay, so if we let u be the portion of the integrand whose derivative is simpler than u, then dv will be the remaining. So we'll see how some examples work here and feel that out. One more little key is that dv always includes the dx, all right? So that's important. All right, so let's try this out. Let's remember the rule. The integral of u dv is going to become uv minus the integral of v du. So again, we've got to define for ourselves what u is and what dv is. That's the key. All right, so we've got a function here, or an expression. There should be a dx there. That's missing. So let's break this up in several different ways and see how it works. All right, so if this is u and this is dv, then we can say, all right, u is x and dv is e to the x dx. Now we're going to use those to find du and v because we need du and v to finish off the formula, right? We know what u is. We need to figure out what v is. We don't know that yet. And we don't know what du is. So we're going to figure that out. Well, how do we get those? Well, we're going to find du by taking the derivative of this. So we can say du dx is equal to the derivative of the right side, which is 1. So in other words, du is dx, or really 1 dx. All right? Well, if we know that dv is equal to the e to the x dx, then we can find that by integrating. So if we integrate here, integrate dv, or really 1 dv, then we have v equals e to the x. All right. So what this does for us is this gives us the option to say, using our formula here, u, which is, so our uv, minus integral of v du. And so uv would be x e to the x minus, and the integral of v, which is e to the x, du, which is dx. And that's something we can do there, right? We can now perform this integral. Okay. And so that would give us x e to the x minus, and the integral of e to the x is e to the x plus c. Don't forget your plus c. Notice we didn't need to worry about the plus c down here because it's going to show up over there. All right, so we got it, but let's investigate some other options here and see how they work. What if we were to choose a different u and a different dv? So what if, let's see here, what if we made this our u, and then we made these two things here dv, okay? So what if we had e dx as our u, and dv is x dx? Well, if we take the derivative here, derivative of e dx is e dx. If we integrate both sides here, we integrate, we get v, and we get x squared over 2. Okay, so what that's going to leave us with would be uv e to the x times x squared over 2 minus v, the integral of v, x squared over 2 du, I forgot a dx here, which is e to the x dx. Well, that is uglier than what we started with, meaning this integral here is not any easier than this, all right? So that was no good. Didn't want to do that, all right, because with this x here, this went to a higher degree. Here, x went down a degree, and it basically disappeared, right? Well, what else could we do? We could say that this is u here. All right, let's say that this is u, and this is dv, like a 1 there. Okay, so let's see what that's going to do. So u is x e to the x, x e to the x, and dv is dx. Well, if we integrate here, we get v equals x. And if we take the derivative here, we got to use the product rule. All right, so this is just going to get what? Derivative of the first times second plus the first times the derivative of the second, which is e to the x, and dx. Well, when we plug that into our formula, which is uv minus v du, u is x, e to the x times x minus, and let's see what the integral is, x du. Well, that's this whole thing. Oof, that's uglier. E to the x plus x. Okay, you can see quickly this is not going to work because our integral did not become any simpler than we started with. And that's our goal, is to get a simpler integral. But sometimes that's a technique that'll work, all right, is using that whole thing as the u. Then the last possible one that we'd want to consider would be this. If this is u is 1 and dv is that whole thing. Well, okay, so u was 1 and dv is x e to the x dx. All right, well, the problem is, in this case, we want to integrate this, and, well, that was the whole problem, okay? Can't really integrate that, and so it doesn't do us any good, all right? We can take the derivative here and get 0, but the integral doesn't work. So, all right, we found out that our best way to go was to take u to be the x, which dropped in degree, and the rest fell into place there, okay? So integrating e to the x was fine. Taking the derivative of x made that drop out. All right, let's try another one here, okay? So here, let's integrate this. Let's try a similar idea. Let's call this u dv. And we have the integral of u dv equals uv minus the integral of v du. Notice the letters switch places, basically. All right? So we come down here. We need to write u equals x squared. And we decide that dv equals the natural log of x dx. So starting it out by defining these things is important. Now we take the derivative of both sides, and we get du equals the derivative of x squared, which is 2x dx. If we integrate both sides here, then we get v equals, now here we ran into a little problem. We haven't done this. It can be done. It's not terribly hard, but that's something we're not familiar with. We could look it up. But we want to kind of back up and say, well, wait a minute, let's change this up because that's not an integral I want to find, or one I can't find easily. So we're going to switch it up here and say, all right, well, let's make this the u. And we'll make x squared and dx our dv. So u is natural log of x. All right, you can find that derivative equal easily. The derivative of that is 1 over x. dv is x squared dx. Got to take that dx with it. And when we integrate this, we get x cubed. So let's see. Let's integrate. And we get v on the left. And we get x cubed over 3. Now we're ready to set this up. So the integral of u dv, we've got uv, so the natural log of x, times x cubed over 3, minus the integral of v, x cubed over 3, du, which is 1 over x dx. And don't forget that dx here. All right. Then that's something I think we can deal with. So this here is going to give us that ugly expression there. How about we pull the 1/3 out? X cubed natural log of x. All right, something like that. And then let's integrate this. This becomes minus And let's clean it up. We've got x squared over 3 dx. We can even pull this 3 out. I'll do that. 1/3, that is. And that's something that we can work with here. So we're going to have x cubed over 3, which is going to end up being 1/9 x cubed, right? Or x cubed over 9 plus c. So pretty ugly, but it worked. All right, and so there we kind of just had to decide, what do we want to take the integral of? Do we want to take the integral of natural log of u, or do we want to take it of x squared? And so we didn't want to mess with the integral of natural log of x, so we wanted to go with the x squared. All right, so now what about this situation, arc sine? All right, we've worked with arc sine before, but we've never really done the integral here, okay, of arc sine without having a u substitution. That worked nice. So the key here is to think of this as 1 times arc sine. So we're going to rewrite this as 1 times arc sine of x dx, and we'll let u be the arc sine. So there's u, and v is the 1 dx. So u, actually dv. U dv. So u is arc sine. We'll take the derivative of that, okay? We're okay taking the derivative, we're just not okay integrating it. That's the whole problem. So u is arc sine. So we can find the derivative of that. That's easy. Derivative of arc sine, we know 1 over the square root of 1 minus x squared dx. And then our dv is 1 dx. And let's go backwards and find v. Notice I'm writing another form. Here's another way some people like to write it here. We knew these two, and we're computing these other ones. All right? So this gives us, if we integrate both sides here, we get x dx. Sorry, we integrated. No dx there. All right. So let's put it all together. We have uv, or I'm going to flip it around, v times u, just to put that x out in front, arc sine of x, minus v du, the integral of v x times du, which is 1 over the square root of 1 minus x squared dx. All right. Well, the question is, can we take that integral now? We had an integral that we couldn't deal with to start, but hopefully we can deal with this integral now, and I think we can. So let's keep going. We've got x arc sine x. And now we're going to use a little u substitution here, but I don't want to use the letter u. I've already used the letter u before and don't want to mess it up. How about a w substitution? Let's let w equal 1 minus x squared. And then we'll take the derivative there. dw is negative 2x dx. So now let's rewrite this integral. We need a negative 2x. We don't have a negative 2 there, so we're going to need a factor of negative 1/2. And so now we have dx, or actually, sorry, dw. And we've got 1 over the square root of w. Okay, we're getting somewhere. So we have arc sine. We've got the half. This is w to the negative 1/2. And we're going to add 1. And so use our power rule here. We're going to add 1 to negative 1/2. We'll have positive 1/2. So w to the positive 1/2 divided by 1/2 plus c. And these halves are going to cancel. So finally we have x arc sine plus w, which is 1 minus x squared to the 1/2 or the square root. There you have it. We did it. uv minus v du. That's the key. All right, one more example. Okay, you got your formula down. U dv equals uv minus the integral of v du. All right. So now we're going to look at one that's going to require repeated integration by parts. Okay, so let's try this out. Here we've got u to be x squared. So du is going to be 2x. That's kind of nice because it dropped a degree. And that means dv would be sine of x dx. And if we integrate this, both sides, we get the integral of sine is negative cosine of x. All right, which leaves us with uv x squared times cosine x, and there's a negative in there, minus the integral of v, which is negative cosine x. I'm going to take that negative and put it out here as a positive. V, that is v du. So du, it would be 2x. Forgot a dx there. So 2x dx. Well, this still has an x in there. So let's rewrite this a little bit to clean it up, and we'll attack that next integral. So we got negative x squared cosine x. Pull out the 2. And let's just rewrite this as x cosine x. And we might say, well, man, we started with x squared sine x. Now we got x cosine x. It's still kind of complicated because we got a product. Well, the nice thing that happened here is that the exponent went down. So now we're going to go round 2. Okay. We'll say, let's let u equal x. And so du equals 1 dx. Take the derivative both sides. Then that leaves us with, so there's our u, and there's our dv. So dv is cosine x dx. So take the integral of both sides. V equals the integral of cosine, which is sine of x. And that gives us everything we need to break this up one more time, and we should be able to tackle it. So let's go with x squared cosine x, actually it's a negative from up above, plus 2 times, and we need to carefully write out another integration by parts. So the new u, which is x, times v sine x, minus the integral of v sine x times du. And du was 1 dx. And that looks doable. I think we can do that. So we've got negative x squared cosine x plus 2x sine x. And then the integral of sine is negative cosine. So this is going to be positive cosine x dx. I'm sorry, what do we do? Positive cosine, no dx. Plus c, that's what we want. And one more little thing I missed. This 2 gets distributed here, so got to watch out for that. Actually, I should just probably have these parentheses there. That's what we should do. So last, negative x squared cosine of x plus 2x sine of x plus 2 cosine of x. And then 2 times c, well, that's just plus a different c. Sometimes we'll say c1 and c2, but it's constant. Great. Well, that's the idea. Okay? So notice it's nice when we choose a polynomial for u because it just gets knocked down. du, and then it gets knocked down again. Okay? So some common forms here to use. If we have a power of x times e, okay, then we'll let u be the x to the n. If we've got x of n times sine or x to the n times a cosine, let u be that x to the power. Okay, if we have x to the n times a natural log or times arcsine or times arctan, then let u be the natural log of x, the arcsine, or the arctan. One way I like to think of it is I don't want to integrate those, so I'm going to let those be u, because u is what we're going to take the derivative of. Okay, here, these are the u's, because I can take their derivative and the other integral is pretty simple. Okay, I can integrate these things, but here I don't want to try to integrate that. Okay, so remember that dv is going to get integrated. So whatever you choose for dv, you got to be able to integrate it. And one more, if we've got a number in here like the sine of 2x or 3x or 4x or the cosine there, that's a little tricky to integrate the sine of 2x or the sine of 3x or the sine of 4x, so we don't want to integrate that. So again, we're going to let u be these sines here or the cosine, because it's not just one x, it's multiple of x. Okay, so decide what you want to integrate. Okay, that's kind of a simple rule that I think works best. And then make that dv. Okay, so by making that dv, then that's the thing that you're going to have to integrate it. Okay, all right, so choose dv sometimes before choosing what u is. So again, it's something that will just take some practice deciding what u and v are, but you'll get the hang of it. And if one doesn't work, then just try a different one. Now you've got another tool in your toolbox. When other tools don't work, see if you can use integration by parts.